Howdy folks, welcome back to Research Methods. This week we're taking a look at your choices for experimental methods. We've finally gotten to what you can do to do an experiment and make sure that you do it correctly. So there's a lot of validity work that we're going to be talking about here, a couple options that you have, and maybe giving you some examples of what some actual experiments might look like, or how to assess things that might seem a little bit too complicated to do through normal research methods. So what sections have we got? First, design options, just giving you an idea of what choices you have to do different types of experiments. Then we'll take a look at internal and external validity choices as well as some validity options. So internal and external validity will deal with problems that you can face, whereas validity options are some choices on how to work with those issues. And finally, we'll take a look at how to write a discussion section and an abstract for your paper. These will be the last sections that you'll write for your paper before you fix them all up and put them together for that final paper submission. So let's get started. What design options have you got? Well, there's lots of different things that you can do, but in actuality they are not particularly complicated and they're not that crazily different in their overall scope. So when you're working with designing your experiment, the first thing you want to think about is whether or not you should have a control condition versus an experimental condition and what you can do to make that work for you. The reason for that is that really it comes down to validity, but what's going on in an experimental design, what makes an experimental design valuable is that you have control over everything. You don't want to have any third variables, any confounding variables, and you want to be able to isolate what you're actually working with. That's what makes the experimental design more valuable than the correlation design. That's what makes your experimental research causal. You can say that you've isolated one thing. So if you're doing research on, okay, does this pill help you lose weight over the course of 2 months, or does eating chocolate help you lose weight over the course of 2 months? Well, you want to make sure you can isolate just that pill or just that chocolate and what its effects on losing weight are going to be, versus a correlational method where you might just observe a person's life and see whether people who eat chocolate versus don't eat chocolate lose weight or something. So the way we can make sure that we're controlling for things very well is by having an intelligent and well-designed experimental group versus control group. So just to be clear, the experimental group in a research design is the group that receives whatever treatment is part of your major research design, and the control group is going to not receive that treatment. So if you're looking at does chocolate make people lose weight? So if you eat chocolate, does that make you lose weight? Your experimental group should obviously be a group of people who eat chocolate, and the control group should be a group of people who don't eat chocolate. But the thing is, you have to be careful of that, because how closely can you mimic eating chocolate? Does eating a vanilla bar help too? Let's think about this in terms of an experiment involving children. So let's say that you are a teacher for second grade, and you have a bunch of second grade boys that are really, really, really rowdy, and so you want to do something about that. You want to calm them down using some sort of intervention, maybe an intervention about self-control. So you design this 2-month-long self-control intervention that you give all of your second grade boys, and after the end of those 2 months, they're 50% less rowdy. Unfortunately, because you don't have any control condition, you can't really say that they're less rowdy than just a regular group of boys who hadn't received that 2-month intervention, because you didn't have anything to compare to. You can compare to before the intervention, but 2 months is a very long time for second grade boys, and so in the course of those 2 months, so many different things could have happened, and they could have simply just grown up a little bit and become a little bit less rowdy. So having that control condition is going to make things better. You could have half of the boys get the self-control intervention that lasts 2 months, and the other half of the boys get no intervention. But then again, you want to be careful, because if you have a 2-month self-control intervention for those young second-year-old boys or second-grade boys, and you don't have anything going on for the other group of boys, well, it could be that just being in class for an extra hour a week for 2 months calms the boys down. Or maybe talking to the experimenter or listening to the experimenter or doing maybe you were doing some self-control exercises, but doing any sort of exercises could calm the boys down. So one thing you want to be careful about is how well crafted your control conditions are going to be. And the thing is, you want those control conditions to be as close as possible to your experimental condition. So if you have those second grade boys complete self-control worksheets every day for 2 months, maybe what you need to do is have the control condition boys complete math worksheets every day for 2 months, so that they have a similar level of exhaustion, a similar level of experience, so that they do almost the same thing, and the only thing that's different is that experimental variable, whether or not they get the self-control intervention. In the research that I do, I mostly have interventions that have to do with studying a certain way or making judgments about something, and so it's very common for people in my area of research and in many areas of research to just have people do puzzles or brain tasks instead of whatever intervention they normally would have gotten, because that at least gets you somewhat in the same ballpark of exhaustion and mental activity as the experimental condition. Alright, so what options have you got? Probably the most common forms of experimental designs are going to involve multiple conditions or multiple baselines. We just talked about a two-condition design, where you have an experimental group and a control group, and the experimental group gets the treatment, the control group doesn't. In a multiple condition design, you might have 3 or more groups that get different types of conditions. So you might say, okay, well, how does eating different colors of M&Ms change people's happiness? And you could give one group the red M&Ms, and one group the brown M&Ms, and one group the green M&Ms. Are there green? Yeah, I think there are green M&Ms. So you can give each group, so you're like 5 or 6 different groups of M&Ms, and you see whether they were happy, how much their happiness changed from before to after they got the M&Ms. So the multiple condition designs are not too terrifying, and you just have more different groups. One thing you want to be careful about is if you have more conditions, you also are going to want to have more carefully crafted control groups, because the more conditions you have, the more variability there might be in what happens in the experiment. So you have more things that you could, more third variables or confound variables, things that you could say were the true cause of the effect instead of just whatever you were trying to experiment on. Another form of experimental design is called the baseline design or the multiple baseline design. The idea for this is, let's say that you have a group of 10 rowdy boys, and the thing is, you have to give all of them the intervention, because it wouldn't be fair to only give some of the boys the intervention to make them less rowdy. Think about this in terms of medical setting. So if you have 10 people who have a phobia of dogs, it would not be ethical to give some of the people the treatment for the phobia and some of the people not get the treatment for phobia. So what you can do in those situations is have a multiple baseline design, and what you do there is you have everyone different people in the experiment they all get the treatment, but they get that at different times. So you can see what changes happen over time. So you can say one person gets the treatment immediately at the start, the next person gets the treatment a week after, the next person gets the treatment a week after. And so by the end of the 10-week period, everyone's had the treatment for at least 2 weeks, and if you want, you could make sure that everyone gets a full 10-week treatment, but that your research data gathering ends after the 10-week design or something. The purpose of this, the value of this, is that you get to see what is happening over time. Remember that we mentioned that, well, maybe the boys simply get less rowdy just because they're growing older over time. And so if you have these multiple baseline designs, you can actually see how at every part in the experiment, how someone is changing or a group of people are changing over time with versus without the intervention. Okay, what else can we do? Well, one thing we want to be careful about when we do research is to avoid testing effects. And so in this situation, you might have well, what a testing effect is what happens when you take a test. You get better at that test. And so if you have a study where you take a math test and then you take a nap and then take the math test again, and you're trying to see, well, how does taking a nap affect people's ability to do math? Part of the thing is, yeah, the nap is going to help you do math better, but also taking the test a second time is going to make you do better on the test as well, because you have some practice with the test, you have more idea of what's going on the test. So what you can do to deal with that is have a complicated design here that sets you up so you can see everyone at every possible condition. What am I talking about? Okay, well, let's say we have an experiment here where you have one group of people take the pretest, so they take the math test, then they take the nap, and then they take the math test again to see how much they changed after the nap. Your next group of people does not take the math test at first, but they do take a nap and then take the test. So then we can see, we can compare the people who took the test twice versus only took the test once, but both of them got the nap. So you could see, well, how much of an effect did taking the test twice have compared to just taking it the one time after the nap. And then the same thing for two more groups who did or did not take the test before. They did not take a nap at all and then took the test a second time or maybe the first time. The idea of this being, okay, so in the first group you can see what is the effect on your math test if you take the test first and take a nap. What is the effect on your math test if you don't take the test first but you do take a nap? What is the effect on your math test if you do take the test first and don't take a nap? So this condition is going to be particularly exciting to compare to this other condition. These two conditions are going to be what most people would use as their regular experiment. A nap versus a no nap. But these two conditions are going to be what you can use to check, well, what was the effect of just taking the nap? What was the effect of not taking the test? And so that helps you understand how well do people do here. You could consider this as one type of control. You can consider this another type of control. You could consider this a third type of control, and then you have your actual experimental condition. By having multiple different types of controls, you can rule out a bunch of different possibilities for your study. You could rule out a bunch of different limitations for your study, and you could be very confident about the effect of that nap. Okay, here's another example of an interesting design. This is a design that I've used, and it's really not that complicated, but I made a fancy little graph to understand what's happening. This is a methodology for a study where people are going to guess what grade am I going to get on a test. So it starts over here. Then they take a test, and then they say, well, what grade do I think that I got on that test? Then they take one of 5 different interventions or a control condition. So some people practiced the material on the test. Some people were told that if they make really accurate grade predictions, they'll get $20. Some people were told that making really accurate grade predictions is actually very good for your overall school success in your career. So they had five different interventions plus a control condition where they just did puzzles. Then they made a prediction, took a second test, and a postdiction. And so the way we analyze these data were to compare predictions to predictions for the first test and the second test, as well as postdiction to postdiction. So compare how well do I think I did on the first test versus how well do I think I did on the second test. And in both cases, we were checking the accuracy of those predictions. That's what we call calibration. And so when I presented these data findings, I would present them in a graph like this, where I set the control condition to be 0. So in actuality, in this study, people got a little bit less accurate or more accurate in their grade predictions between the first and the second test, and so we subtracted that out so that we would just look at the effect of the interventions. And you could see some interventions actually made people better, much better at making predictions, and actually this intervention made people worse at making grade predictions compared to the control conditions. So it was a pretty interesting study, and it was very, very difficult to deal with this data initially because we had a bunch of different data points. We had, if you look here, 1, 2, 3, 4 times 6 data points. So we had 24 data points. How are we going to analyze that data? How are we going to make sense of that? I don't know, but if we turned it into something that works as simple as this, we can say, okay, well, here's the change in calibration, and this was, I believe, for the predictions, so we had a very similar graph for the postdictions, and we could say, well, both of the graphs looks pretty much the same, so we can conclude that they both give us the same results. Okay, so in the next section, we'll talk about some internal and external validity issues. I hope these examples of different real-life research paradigms have been interesting and useful to you. If you ever do research on your own, you may need to come up with your own version of your experimental design, and the best way to do that is to take a look at what other people have done and see what has worked for them. All right, we'll talk in a minute.